This is lesson 3.2 on polynomial operations for Pre-Cal 10, Foundations in Pre-Cal 10, starting on page 135. We are going to do the work with algebra tiles here because it does help make some sense of some things. So in previous courses, we multiplied two monomials together, or a monomial times a binomial or a trinomial, and we're going to just do a quick review of that using algebra tiles. So here we have, this is the 2, oops, this is the 2, this is, oh shoot, this is our x plus 1, and we're going to multiply them together. And the way we do that is, well, the way I describe it is wherever there's a gap, there needs to stay a gap. So there's a gap here, so I need a gap all the way down there and a gap here. And then I can do this tile is like this. And then there's a gap here, so there's a gap there. And then since I've got a positive times a positive, I'm going to end up with a positive.
Sorry for the interruption. Grade 9 students, last name is T through Z. If you wish to have a retake photo, please send to the theater. That's grade 9 students, last name T through Z. Please send to the theater.
So I'm coloring it in green because it's faster than using the pencil on this. So my answer here is what I have left here, which is I have 2x plus 2. Okay, and I invite you to pause the video and do these one at a time to make sure that you're getting the right answer. So pause the video because I'm going to color it in while it's paused. So for B, I get x1, x squared, and 3 x's. Pause this and do C. This time I have -3 times x minus 1. So a negative times a positive is a negative. So all these are negative. But then we have a negative times a negative, we have a positive. So these bottom ones are going to be colored in. Okay, so that means that our product here is going to be -3x, because I've got 3 negative x's, and I have 3 1s. So I just write that as plus 3. All right, pause it, do the next one. Okay, see how there's the gap that runs all the way down and all the way down across and all the way across. So here I have 2x squared minus 4x. Okay, pause it again, go do the last example on this page. So the product this time is 2x squared minus 2x's. Okay, next page. We're now on page 136 and doing example 2. So each diagram here is the results of the product of a monomial and a binomial. So the monomial will go up here and the binomial will go down here. But let's follow through here. So it says state the polynomial represented in these diagrams. So that's actually asking us for what is here already. So this is 2x squared minus x, okay, for both of those. And then it says complete the left side and top of diagram 1 and write the polynomial product. So the one way we can do this is by putting an x and an x and an x, and so those are the shapes that we need, right? And so this is, if this is positive, oops, I don't have that pen, hang on. Oops, draw. There we go. Okay, so if this is positive, then this is positive because a positive times a positive is a positive, and this is positive because a positive times a positive is a positive, and then this one is negative because a positive times a negative is a negative. So the polynomial product, what we have, this diagram is showing is x times 2x minus 1, and that equals 2x squared minus x. Okay, And then we can do this in diagram 2, and we can do something different. This time, we have to do the same shapes because the shapes are, we have to have those gaps where the gaps are. But if we're going to do this different, if we make a negative times a negative, that is also a positive, and then negative times a negative is also a positive. And then we need to make this one here a positive because a negative times a positive is a negative. So that gives us the other way of doing this, this result. So we can have negative x times negative 2x plus 1, and that also equals 2x squared minus x. And then this question here where it says write each as a sum or difference of terms, I have no idea what they mean when they do that, so we're just not going to worry about it. Okay, and now we're going to verify these equations when x equals 3. So let's just talk for a minute about verifying your answer. What we've done up here is we've said that this side here, the left side, equals the right side, no matter what x is. So I can pick any value for x and plug that in there, and I should get that the left side equals the right side. Now, I don't want to pick 0 because zeros just cancel things out sometimes. Like if I made this 0, this is going to be 0 no matter what's in here, and it's not going to catch errors. Anytime you have an x squared, 1 is not very good because 1 squared, 1 cubed, 1 to the 4, they're all the same thing. So again, that's an error that you're unlikely to catch. So instead, it says to use x equals 3. Okay, so I'm going to do this one on the side. So I have x times 2x minus 1, and this should equal 2x squared minus x. So then I'm going to replace my x with 3. So this becomes 3 times 2 times 3 minus 1. So that's 3 times 6 minus 1. So that's 3 times 5, which is 15. And on the other side, I have 2 times 3 squared minus 3. So that is 2 times 9 is 18 minus 3, which does also equal 15. So that side is correct. And then let's do this one over here. So I already know that the 2x squared minus x is going to equal 15. So let's just do the other half. So I've got minus x times minus 2x plus 1. Put the 3's in for the x's. So I've got minus 3 times minus 2 times 3 plus 1. So negative 3. Negative 2 times 3 is negative 6 plus 1. And negative 3 times negative 6 plus 1 is negative 5, so that equals positive 15. So yeah, that still equals the 15 all across. So I verified that that is correct. Okay, so that's the end of this video. You can go and do practice questions 1 to 3 and then come back and see the rest of the video.